Hey AL physicists, what's the crack? So today what we're doing is we're looking at energy level diagrams. So what it says here is we've got the hydrogen atom, and these are energy levels in the hydrogen atom. So you've got your ground state, your first excited state, second excited state, third excited state, and fourth excited state. And they've given you the energies of the states in electron volts. Remember, like 1 electron volt just means you multiply by 1.6 times 10 to the negative 19 to put that number into joules, okay? Because that equation E equals VQ, so E equals VQ. So to put the electron volts into an energy, you just multiply by the charge of the electron. Okay? But we don't need to do that for this question. We should figure out how many different EM waves could be emitted. So what it says is we're colliding with the hydrogen in its ground state. So you've got to imagine I've got an electron here in my ground state and colliding with it with 13 electron volts. So this level here is 13.6 electron volts. If I add 13 electron volts, I'm not going to be able to get up to the n equals 4 level. I'm only going to be able to excite it up to the n equals 3 level. Okay, so if we look at that again, if it's 13.6 electron volts is down here, if I add 13 electron volts, I can only get to 0.6. So I don't have enough energy to get it bumped up to the n equals 4 levels. That's why we have to end up in the n equals 3 level. So that's where our electron's going to end up when it's excited. And then we know when it de-excites, when it falls back down to a lower energy level, what it does is it emits an EM wave with energy equal to that energy level gap. So whatever the difference there is in those energy levels, that's the energy of the EM wave that'll get emitted. And we know E equals HF or E equals HC over lambda, so we can figure out what that wavelength is then of that EM wave emitted. So we know there's one thing it can do. So when it falls to here, that's one EM wave emitted. Then it can fall from n equals 2 to n equals 1, get another EM wave emitted, so there's number 2. Then it can fall from n equals 1 down to the ground state, there's 3. There's another EM wave emitted. But then instead of it just falling down to the n equals 2 level, our electron could fall straight back down to the n equals 1 level. So there's another EM wave emitted, so there's now 4. Okay, then we've already got the transition from here to here, so that one doesn't matter. Then another transition we could do is we could say the electron falls from here the whole way back down to where it ended. So here falls the whole way back down to where it started, and there's another EM we've emitted. So clearly we've got 5 so far. And if we look at it, there's still a 6th one, because what we said was number 1 was falling from 3 to 2, and then it went in stages down. But what it could do is when it fell to here, instead of falling to here and then down, it could go the whole way down to the bottom. So there's our 6th EM wave that could be emitted. So in total, we have 6 different EM waves that could be emitted.